We tend to forget the violent, erupting reality of the neighborhood we live in. Every single second, our planet is bombarded by a relentless stream of lethal radiation fired out from the sun. An invisible magnetic field wraps around the globe, deflecting the cosmic crossfire safely away from the surface and preventing our atmosphere from boiling away. Today, our most critical infrastructure leans heavily on this invisible barrier. Satellites passing through orbit and global navigation systems guiding ships across the oceans rely entirely on this magnetic field holding steady. Without this exact planetary shield, Earth becomes immediately uninhabitable, and the technological network we've built our modern era upon ceases to exist. We naturally think of the Earth beneath our feet as solid, permanent rock. That quiet surface sits atop a highly volatile liquid engine, separated by only a thin layer of brittle crust. This diagram shows the inner structure of the planet. Notice this specific area, thousands of kilometers down. This is the geodynamo, an ocean of churning, superheated liquid metal that actually generates our protective magnetic shield. For decades, geologists assumed they had a firm grasp on how this subterranean ocean behaved, expecting it to follow a very slow, highly predictable rhythm. Recent satellite data has shattered that assumption. Observations confirm that the planet's engine is highly volatile, and right now, it is doing something entirely unexpected. To see what's going wrong, we have to travel directly beneath the Pacific Ocean, descending exactly 2,250 kilometers underground. Down here, the physical makeup of the Earth consists of a massive, incredibly dense river of molten iron. Before the year 2010, the historical baseline for the specific iron current was incredibly stable. It flowed continuously in a steady, reliable westward direction. Geologists mapped this westward flow as a dominant, permanent structural feature of the Earth's interior architecture. Because of that stability, researchers operated under a very specific assumption that massive deep Earth changes require millions of years to unfold and would absolutely never happen within a single human lifetime. That theory collapsed when a research team from the University of Edinburgh began analyzing ground observations and satellite tracking data spanning from 1997 to 2025. This chart tracks the flow of the molten iron river beneath the Pacific. You can see the steady westward trend over the late 90s and early 2000s. But look what happens in the year 2010. The data line abruptly flatlines. The massive current completely stopped moving. Immediately after stopping, the data line violently spikes in the exact opposite direction. The river of molten iron suddenly started surging eastward. Now, the latest tracking data provided by the European Space Agency shows another twist. This aggressive eastward flow recently peaked and is already weakening. This rapid 10-year shift forces scientists to answer a difficult question. They have to determine if this reversal is a temporary glitch, part of a fast-moving recurring cycle, or an entirely new, long-term baseline for the planet's core. Let's bring our focus back up through the mantle, returning to the surface where we live. Despite how dramatic a reversing planetary core sounds, we are not facing a sudden climate collapse or an apocalyptic scenario. The shifts happening thousands of kilometers underground do not pose an immediate biological threat to human life. You are physically safe. The actual consequences play out on a systemic infrastructural scale. Because the liquid core generates the magnetic field, as the iron river evolves, the magnetic shield slowly morphs in response. We built our modern society heavily relying on the illusion of a static planet. As the magnetic field changes, our technological infrastructure is entering highly unpredictable territory. Because the liquid core is constantly churning and reversing its flow, the projected magnetic field is actively warping, bending, and shifting right along with it. This creates direct friction on the surface. Global shipping logistics and maritime navigation rely on incredibly precise magnetic coordinates. Those coordinates are now moving targets. Further up in orbit, multi-billion-dollar satellites now have to navigate through increasingly volatile space weather patterns, driven by these exact same magnetic shifts. The boundary between the core and the mantle is an incredibly active frontier. If we want to maintain the modern infrastructure we rely on, we have to recognize that the planet we live on is a volatile, living machine, and it refuses to sit still.